Hello everyone, let's solve one question from EMT. The figure shows below an ideal capacitor consisting of two parallel circular plates of a radius capital R, as you can see in the figure, and P1 and P2 are at transverse distances from the axis of the capacitor. Okay, and this is at a distance R1 from the central axis of the capacitor. Suppose this is R1 and P3 P4 are at a distance R2 from the distance from the central axis of the capacitor. Okay, and then we have to find the magnitude of Bx at these points uh, when while the capacitor is charging. Okay, see, one current is passing through the capacitors. Let me draw again. See, that is the capacitor and a current is passing through the central axis of the capacitor, so that as current is passing through this capacitor plates get charged. Okay, it will be positive charge, it is negative, so that the electric fluxes will passes from one capacitor to another. The fluxes are like this, and this is in between the capacitor there is a vacuum. Okay, and one point is here inside the, that is inside in between the capacitor. Okay, P3 and another is at P4, and another two is at P1 P2. Okay, so by using Ampere circuital law, you can find out the magnitude of magnetic fields. Indication of beta dl is equal to mu naught I enclosed, you know. So first let's try for P1 and P2. For P1 P2 both are at same distance, that is R1. So integration of beta dl is the 2 pi r. R1 is equal to mu naught I enclosed. I enclosed is I. So that B is equal to mu naught I by 2 pi r R1 for both same magnetic field. B1 is equal to B2. So you can say that the magnitude of BP1 is equal to BP2. Okay. So option 1 and 2 get discarded. Only left 3 and 4. So let's find the magnetic field at P3 and P4. As you can see that you know that in between capacitor there is one current that displaces the electric current from one plate to another plate by changing electric flux. Okay, that you can say that displacement current in between the capacitor, and that capacitor is at in vacuum. Okay, there is uh, nothing material things, there is vacuum, so that there is only current is displacement current, and that is only due to the changing electric flux. Okay, so at P3 integration of beta dl is equal to mu naught I enclosed. Here that is not I enclosed, that is the displacement current. So B dot 2 pi r is equal to mu naught I displacement current, and B is equal to mu naught ID divided by 2 pi r. Okay, and see here that you know that the displacement current density is equal to mu naught del E by del T, and you know J is equal to I by A. So I by A ID, if I multiply here that A, so E dot A is the flux, so mu naught del phi by del T is the displacement current. B dot mu naught, so B equal to mu naught divided by 2 pi r, and ID you can write that mu naught del phi E by dt. And see here that the circular loop enclosing is less, because there is more flux outside the loop. As a less flux change, so less current and less magnetic field. So at point P3, the magnetic field is less. And if you try to find the magnetic field at point P4, magnetic field at point P4, here the current is due to only enclosing current is the conduction current, and always our conduction current is more as compared to the displacement current. So B dot 2 pi r is equal to mu naught I, conduction current is the I enclosed. So magnetic field at P4 is equal to mu naught I divided by 2 pi r, as both are at same distance from the central axis of the capacitor. So magnetic field at point P4 is greater as compared to P3. This is because that our displacement current is less at point P3, and our conduction current is more at point P4. So I hope you get all my points. So thank you. Our option is matching option is not 4. This is option 3. So thank you.